Welcome to the new session. In today's session, we will be learning about what do you mean by the orthographic projections. And later on, we will be able to draw the different views for the given isometric object, or we can also call it as the 3D object. So let us proceed. What do you mean by the orthographic projections first? So orthographic projection is a technical drawing in which the different views of an object are projected on different reference plane and observing perpendicular to the respective reference plane. So that's why the name is given as orthographic, that is perpendicular to the reference plane. So based on this, the different reference plane and the different views that we are going to obtain are. So the different reference plane is horizontal plane, generally abbreviated as HP, vertical plane, which is abbreviated as VP, and sometimes we also get the abbreviation as side or profile plane as PP. So the top view is obtained on a horizontal plane, front view is obtained on the vertical plane, and side view is obtained on a profile plane. Sometimes also can be called as side plane. For a general reference, we can call it as. Now, based on the orthographic projections, how do we look at the object? So projection in which the projectors are parallel to each other and perpendicular to the plane. You can see that. So if this is object which is given, right? This is the suppose the site of the observation from the perspective of the observer. So if the observer is looking at this object, which is nothing but perpendicular to this particular plane, right? So what we are going to get? So here it is assumed that this green arrow shows the front view. That is, this is the observer location. So from his perspective, what we are going to see? We are going to see this. That is nothing but a direction for the front view. Correct? So this is the, we see that this is particular direction in which the observer is looking. Then as far as the observer is concerned, this is the arrow which indicates a side view. From the perspective of the observer, this will be the right hand side view. Correct? And for obtaining the top view, which is we are going to get it on the, we can say top plane or horizontal plane. This is the direction in which the observer will be looking at. So based on this, if the observer is looking in this direction, we are going to get the front view. So what we are going to get? We see that we will get a shape like this. Correct? So we see that this is the shape, which is nothing but a L in this case. Correct? So looking in the same direction, but while looking from the top, what we are going to see? We see this portion. Correct? So for getting that portion, as well as for getting this portion, what we will be doing? We will be drawing a line from the projection, or by projecting the line in the horizontal plane to get the top view. So for that we need to know what is the this distance. Correct? So we project this like this. Then once we know this distance, we will also project this line. Correct? And finally we will be projecting this, which is nothing but we can say that after shifting this by 90 degrees, we get this portion. So this is the one portion which is referring to this, and this is another portion which is referring to this portion while looking at the top. Similarly, this violet color arrow shows the right hand side view. Now currently only focus on what we are going to see, right? We will be discussing later where to locate this object and how to locate. So while looking in this direction, we see that these are the two rectangles. This is the first rectangle that we see, and just above that we see this rectangle. Okay, so this is the one rectangle and this is the another rectangle just below it. So how do we obtain that? This rectangle can be obtained by, we see that it is touching the bottom, So this is the portion that we see first, correct? And above that, we will see these portions. How do we obtain this? Just project this corner and we will be drawing this portion, right? So in short, we can see that if this is the object, if this is the object, right? And this is the observer side, right? So observer, we see that towards the object, right? And these are the arrows which are coming from the object to the observer, right? And we see that the projection is obtained on this plane. Okay, so in this case we see that the side of the observer is perpendicular to the plane of projection. That's why it is orthographic. Okay, so we will not be discussing about this third angle method of projection. Okay, we will only focus on this first angle method of projection. Now understand what is meant by first angle method of projection. So let us assume that the object is placed in the first quadrant. How do you understand it's the first quadrant? See that this is the vertical line, this is the horizontal line, and the object is placed here. Okay. So now, where is the object located? In the first quadrant. Suppose now this is the observer, right? The observer is here, right? And this will be then front view. We are going to get the front view on this vertical plane, right? Then as far as the observer is concerned, this will be the right hand side for the observer, correct? So the right hand side will be projected on this particular plane, right? And as far as the observer position is concerned, in this direction the observer will be looking, right? So the projection will be obtained on this horizontal plane, right? So there are three views we are going to get. Observers looking in this direction object, which is nothing but red color highlighted here. This we are going to get the front view, which is projected on this plane, right? Then looking in this direction, arrowheads, the projection is obtained on the horizontal plane, right? And in this direction, as we are looking from the top of the object, we are going to get this green color object that we see is the top view. Similarly, whenever the observer is looking in the direction, at the same time observer can also look at this diagram or the object from the right hand side. So this right hand side projection will be projected on the left plane, correct? So in this case, this yellow color highlighted portion will be observed whenever the observer is looking from the right hand side, as well as we will be able to see some additional portion, this greenish portion. Okay, and how do we indicate this? This is the symbol which is followed for first angle method of projection. Okay, you can ask me any doubt in between. So if you have understood this, how do we get the three views? First is the front view, top view, and the right hand side view. Okay, mostly in exam, depending upon the pattern in which you are going to give the exam, either you will be given or you will be asked to draw front view and top view, or front view and side view. Side view could be right hand side view or left hand side view. Okay, so let us look at in detail. Again, this will be I am skipping with, because we are not going to follow the third angle method of projection. So we will be only focusing on the first angle method of projection, in which this diagram, if we are looking at, this is the direction for the front view. Okay, so observer is looking at this object. So what we are going to see in the front view, we will be seeing this T shape, inverted T shape. Besides the inverted shape, inverted T, we see that this is the portion and this is the portion. So on the either left and right, we see that this portion, right? So this is the front view that we obtain by looking in this direction. Similarly, if we look it in this direction, we see the T shape again, this T shape, correct? So how do we get this T shape? just by projecting this. So we can see that this is the projection we obtained, right? And between this projection, this is the object which is away from the observer. So this is the portion which we will draw first, correct? And we complete this T shape, right? And while looking in this direction, we see that after this T is visualized, we see that there is one more portion here on the right as well as on the left. So we complete this portion I am referring to. So this is how we obtain the top view. Similarly, we can have the right hand side view looking in this direction. So now as far as the first angle method of projection, where we should draw the right hand side view. The right hand side view is obtained on the left plane. This is the left plane, and as far as the observer is concerned, this will be the right plane. So while looking in this direction, the projections are obtained on the left side profile plane. So this will be left side profile plane, and to match or to draw it on a piece of paper correctly, so we need to rotate this by 90 degree like this. So after the rotation, we see that the right hand side view will appear on the left of the front view. So always remember, in the first angle method, right hand side view is on the left and top view will be below the front view, and if at all it has a left hand side view, it should be on the right of the front view. Okay, this needs to be remembered. And how do we get to know that this is the first angle method of projection? By looking at this symbol. So this symbol will indicate us that it's a first angle method of projection. We see that the circle is concentric circle on the right and this trapezoid is on the left. Okay, so now let us understand in detail how to get the different orthographic projections. Okay, for this, sometimes this front view is also known by a word called as elevation. Okay, then top view is also known by the word called as plan, and end view is also referred to a word side view. Okay, so sometimes same elevation could be a side view for the observer whenever the direction of viewing is changed. Suppose if we are looking in this direction, right? So what we are seeing, this is the first thing that we will be able to see. What is this? This is the L-shaped portion that we will be able to see whenever the observer is looking in this direction, right? And then also he will be able to see, he or she, this circular portion. Now we can easily get to know that if this is the cylindrical portion, sorry, this is the cylindrical portion, and if the direction of view of the observer is this, then observer will be able to see the edges, right? Observer will be able to see this curved image as vertical, then this bottom edge will be seen as a straight line, and this curve edge will be again look like this. So what does the meaning? The cylinder will be observed as a rectangle whenever the observer is looking at the object in this direction. Similarly, this is the cylindrical portion. So for this cylindrical portion, observer will be able to see, sorry, this is the length, and for this diameter, what he will be able to see? He will be able to see, or she will be able to see portion like this, right? So this is the width of the rectangle, which is this much. The height of the rectangle in this case will be equals to the diameter of the cylinder. So that's why we see that this portion is shown. So this is the L-shaped portion observer will be able to see, and this rectangular portion which is immediately following this L shape, because the cylinder is sticked, or we can say connected to this L shape portion, correct? Now If this is the observer direction to get the front view, then in this direction the observer will be able to get the top view. Now for getting the top view, what we can do, we will have to take the projections, because if we take the projections it becomes easier for us to get the complete the diagram in the other views. So once we know the this length and this height, we will be able to complete the object. Then to get the top view, we will project this by following this arrowhead. No need to draw the arrowheads in the exam. These arrowheads are indicated just for the reference purposes, to show in which direction we are taking the projections. So now once we taken the projections, what we need to know, we need to know how much is the length while looking in this direction, right? So we will mark this edge like this. Then for following this projection, we will mark this line which is equal to the length of this object, correct? Then this cylindrical portion will be also observed as a rectangle in the top view. So for that projection, we will be marking this. Now we need to understand that this object is symmetrical in the top view, right? So that's why whenever we draw this rectangle for the top view position, first what we can do, we can make a line of symmetry. We will understand what do we, how do we draw the line of symmetry by a typical type of a line which is called as a center line. Okay, this is a typical line which is called as center line. So based on that, we will be drawing this length which is equals to the length of the object, this length, correct? Then this length which is equals to the diameter. In this case we will be looking at this direction. So this is the diameter we will be drawing, and finally while looking in this direction we will draw this portion. So we complete this portion. Now you can see that this is the portion which is nothing but outside of the part. That's why it is called as outline, right? And all these lines which are called as a construction lines. So we can remove this construction line if they are disturbing the other views. Otherwise we can retain. And one thing need to be remembered, that whenever we take these construction lines in AutoCAD, so the line thickness needs to be maintained. So what is the line thickness we need to maintain? For the construction line we use the 0.09 mm thickness, and the type of line will be bilayer. Whereas for the outlines we use a bilayer type of line, and the line thickness that we keep is 0.30 mm, right? So this needs to be remembered. Okay, whereas for this center line, what we do, we keep the line thickness as 0.09 generally. Some of the times we may take the different thickness, but I will always suggest to take a line thickness of 0.09 mm. And what is the line type? In this case, the line type will be center line. Now if the observer's direction is given like this, so this is the view that is the observer is going to get, is called as a left hand side view. So in the left hand side view, what we are going to get is the, in this direction the observer is going to get is the side view. So whenever the observer is looking in this direction, what we see is that observer will be able to see this rectangle first, correct? And after that he will be able to see this outer rectangle above the this rectangle, correct? And at the central portion we see that this is a circle which is nothing but a front view for the cylindrical portion. He or she will be able to see. Again, while looking in this direction, that is nothing but a side view for this observer, which is the left hand side view. And as far as the rotation is concerned, we see that the left hand side view needs to be drawn on the right. That's why if this is a front view, this is a top view or a plan, then this will be the left hand side view, which is located on the right of the front view. Okay, so now what we see that these projectors are obtained from the front view to the right left hand side view. This projector is obtained. This is the center line for the circle. Then this is the end of this circular part, and this is the top. These are the projectors that we have drawn. Okay, now we take this rectangle. For to draw a rectangle, we need to know what is its width. This is the width we need to know, correct? The height we will get it automatically by taking a projection. Then after drawing this, we see that this is the rectangular portion above this, immediately following this portion. So how do we get that? This is the boundary, right? So within these boundaries, we will be drawing this vertical portion. As we know that the width of this much portion and width of this portion is exactly same. So we draw these vertical lines between these projectors and correct it. Correct, to complete this outer portion. Okay. Now again we see that this object is symmetrical. So we can draw the center line like this, right? And within the projectors that we have obtained from the front view, we draw a circle keeping this as a center point of the required diameter. In this way, we get the three different views for the given object. Okay. Any questions? Okay. Now let us look at the next object. So let us look at this object given. So in this case, for the given object, we see that front view or elevation is shown by a arrowhead. This arrow. Okay. And this is the direction in which we can obtain the right hand side view, and while the observer is here standing in this direction and looking from the top, the observer will be able to draw the top view. So for this given object, how we are going to get the three views? We need to decide first which is the view we need to draw. That is, which side view is needed to be drawn. As far as this is the arrowhead for the front view or the elevation. So this is the view the observer will be getting is the right hand side view. And as far as the convention is concerned, right hand side view should be on the left of the front view. Therefore, right hand side view is located here. This will be the front view, and below the front view we are going to get the top view. Correct? So once you have decided this, what is the next step? The next step is the observer needs to find out the what are the different overall dimensions of the object. So how do we get that? To get the overall dimensions, right? So while looking in this direction, we see that what is the entire length from the left to right? The entire length is 20 plus 20 plus 20 plus 20. So the total length is 80, right? So this is the length we get. So we draw a box keeping a some distance. So we can take this distance as suppose 10. I will now shift it to AutoCAD so that it is easy to understand. Now, very similar object to the previous one. In this case, the direction of viewing is x and the total length of the object is given as 104, right? And in this case, instead of the front view, we have a left hand side view here. And in this case, the total length is given as 72 while looking in the this arrowhead's direction opposite to the arrowhead, that is from the left hand side. The total length we get is as 72. And so what is the height is given? Let us assume the height as 48. Okay. So this portion is 16, this portion is 16, and this portion is also 16. So the xy line is already obtained here. Let us draw this line vertical perpendicular to that, right? So now we keep we keep a offset. Let us keep the offset of 15. You can also keep the offset of 10 mm like this. Okay. In this case, the line thickness I am keeping is bilayer 0.09, so that whenever the final outline or the final view is to be obtained, it will be thick. Okay. So now what is that entire length while looking in this x direction? We see that it is 104 and the height of the object is 48. So from this corner, we see that intersection is the point. How do we get this intersection point? From this O snap settings. So here the intersection option is on. So we see that it is enabled. We take the 104, then tab, and the height is 48. Enter. Right? Then we get the length and the width in the top view. So the length of the front view and the length of the top view will be same. What is going to change while looking in this direction? In this direction, if the observer is looking towards the object from the top, another dimension obtained is width. So in this case, width of the object is 72. From this intersection, okay, so one thing need to be noted that as this object is sorry involving the left hand side view, front view and the top view, I need to draw the left hand side view on the right of the front view. So here we need to make the correction from the previous object that 104 needs to be taken on the left. Tab, and this is the 48 is the height. Okay. And sorry 104 tab, and here we are going to get the width as 72. Then for the side view, we keep this portion. Then what will be the width of the side view? Width of the side view will be same as that of the width of the top view. That is width of the top view is 72. That's why 72 tab, and in this case height will be of the same as that of the front view. So 48. In this case is 48. So now we change the layer thickness to 0.3 and we will have to switch it on the line weights so that whatever the line weights are changed will be displayed. Otherwise, even after changing the line thickness, line weights are not displayed and the object will not be looked as a thick. Outline will not be seen. So while looking in this direction, we see that this is the L shape that we will be able to see. We start from the A point to B point. Entire length is 104. So this we draw 104. Correct? Then once we reach to the point B, we see that the height of the object here is 48. So we reach to this particular point. Then once we reach to this particular point, we see that this is a line of length 24 which is parallel to the AB but going from B to the A. So going from B to A of length 24. Enter. Okay. Now we reach to this particular point. From this particular point we see that this is a vertical line. This vertical line is parallel to the right side vertical line. Now the height of this vertical line needs to be obtained. It will not be directly given by reading the dimensions which are given on the other side. So this vertical line is composed of these two distances, this 16 plus this 16. So the total height here we get it from the top corner to this corner is 32 because this portion dimension is parallel to this 16 plus 16 because we see that this surface is perpendicular to this surface. So the total length we are going to get is 32. So we see that this 32, enter, and then we see that this portion is ending exactly at the left. So here it is ending and then we can complete this portion. So from this corner, this line is parallel to this 104 mm line, and as we have already drawn the boundaries, we need not to think how much is the left behind distance. So we started from this point and we ended at the point which is exactly above the point of A. Okay. Now, is this the only portion while looking in the front view? No. So what are the other portions that we will be able to see? This. Okay. So this is a portion having the height at 60 and the length as 104 minus 24, which is nothing but 80 mm. So how we can draw this? With this portion exactly start above the point that we have drawn here. So now we take the 16 mm, right, and we complete it at the rightmost portion. So from this point we draw this 16 mm, completed this 80 mm. Similarly above this we draw this 16 and we complete it at the right end in this way. So this completes our front view because these are the only three portions we will be able to see. This L shape, above that this rectangle, and above that this rectangle. Because all these three portions, this L shape, this is the portion and this is the portion, these are all perpendicular to the side of the observer. Okay. Now while looking in the top view, what we see that this is the again L shape is observed, but while drawing this L shape, what we can do, we can take the projections. For taking the projections, which is the line type, sorry, not the line type, but the line thickness from 0.3 to 0.09. So we take this projector like this, right? And what we see that while drawing the top view, there are two positions for the top view. What are the two positions I mean to say? This is the line which is nearer to the observer and this is the line which is away from the observer, right? So the L shape that we observe is that this is the right hand portion for the top view, this is the left hand portion for the top view, and this is the away from the observer and this is nearer to the observer. So now again we shift it to the 0.3 thickness. So we started suppose from this corner which is away from the observer and we draw this line. So this line we have drawn, okay, having the length 72, right? Then once we reach to this corner, we see that while looking in the top view, we see that this portion, now it is of length 24, but as we already taken the projection, no need to take the 24 mm. We take this, okay, distance. Now we have reached to this particular point. Now we need to complete this portion. Now how do we get this? This total length is 72, out of which this is the 24, this is 24, so this remaining portion is also 24, right? So we take the total length of this corner to this corner as 48. So we take the 48, right? After we reach to this particular point, we see that this is a line which is parallel to the boundaries of the object. So we draw this line which is parallel to the boundary like this. So from this corner we have drawn this line. Now we take this portion. What will be the length of this portion? It will be automatically, we will get it as 24, because the total width of the top view is 72, out of which we have already taken this 48. So the remaining portion will be 24. So we draw this, right? And once we reach to this particular point, we complete this rectangle like this. Okay. Now, once we have drawn this, is this the only portion that is visible in the top view? No. So we also see that this is the rectangular portion having the width as 24 and the length as 80 mm. So from this particular point, we draw this rectangle having the width as 24, right? And the length as 80. Just start from this point, take the 24 and reach to this right hand side of the top view. Similarly, this is the another rectangle that we see having the width as 24 and the length as 80. Okay, in this way this portion is completed. Okay, so now we have completed the top view, as well as we already completed the front view. Now let us look at the side view. Now for projecting a side view, what we need to do, again we take the line thickness at 0.09. We need to draw a line which is starting from this intersection. For that, there is a one shortcut here available, is called as polar tracking, to draw a line of 45 degree. From that, we start this line from the center, we take this projection, or we continue that line from the intersection and we extend this line, right? And we can see that this green color dotted line will follow the 45-degree angle. In this way, we can take the line inclined at an angle 45 degree. Now, we take the projections from the critical points like this. In this case, we can switch it on the polar tracking mode instead of the ortho mode, or we can take the ortho mode like this. I will also show how to do. We need to cross it, then extended portion which is beyond this projection line needs to be trimmed, and then we can take the projection from these boundaries to here like this, and we can see that this outer boundary should match with the side view, because the length of the, or the width of the side view will be equals to the width of the top view. So in this way we have taken the projections. Sometimes all the projections, if we take it from the front view and the top view, it will make the side view looking very complicated. We might get confused. So depending upon the requirement, we need to take the projections just like this. If this is the left hand side view, what we see that this is the portion that we see. So for the left hand side view also, we will have the four sides. This is the left edge, this is the left edge, this is the right edge, this is the bottom edge, and this is the top portion. So if we started from the left edge for the left hand side view, what it refers to, this is the left edge for the left hand side view, this is the right edge for the left hand side view, this is the top edge for the left hand side view. Similarly, this will be the bottom edge for the left hand side view. So again shift it to the pointer thickness, right? So let us, we started from the left portion of the left hand side view. What we see that it's a vertical line. So this vertical line we see, right? Then now we need to switch it on the ortho mode. Otherwise we may end up a line which is not exactly vertical. Okay. So here we draw like this. Okay. We draw it like this, correct? Once we reach to this bottom, we say that this is a horizontal line having the width total of 72. So we go here, right? Then we reach to the rightmost portion of the left hand side view. Then this is the width, sorry, not the width, this is the height of this portion. What is the height? We are going to get 16. In this case, either we take the 16 or we can just project it from the front view. So how do we project? We take the line thickness again to 0.09, and in this way we can get it like this. Okay, we take these critical points from the front view. Now how do we complete it? We can complete this portion in one stroke. So once we reach to the rightmost point, we need to see the height of this portion. So height is from this point to this point, right? Now once we reach to this point, we see that this is the 24 mm width we will be able to see. So from this projector to this projector we draw, right? Then we draw this 16. So again already a projector is maintained. So we draw this vertical line here, correct? So now from this point to this point we reach. So we take this, right? Then from this point to this 16. So just we are following the lines between the projectors, correct? Now we draw this top portion. Okay. Now is this the only portion that is visible? No. So what we see is that this is the inverted L shape that we will be able to see whenever we look it from the left hand side view. So where does it start and where there is end? It starts from this corner, it ends at the top, and its end on the left of this corner. So how do we draw? Just take a line command. It started like this. So it starts from this portion. Above it, we reach to this particular point and we reach to the left. That is till the end of this corner. In this way, we take this portion. So now the left hand side is also complete. Now what is the important thing? We shift the line thickness to 0.09. We need to give the important dimensions. Okay. So we give the, what is the overall length here is 172. Sorry, 104. Right. We show here 104. Then we see that what is the height here? It's 48. Right. Then we see that this 104 that we have drawn is very small compared with the size of the objects. How do we increase that? For increasing the size of the object, either we can type the div style command, or we can access the same div style command from the here line weight settings or the here annotations, and this window will appear. How do we get? We get here annotations portion. We go to this. We go to the modify. We need to increase the text height. So the text height, let us take it as 3 or 5 depending upon the size of the object. Then what we need to change? The text alignment, generally we keep it as ISO standard, right? In the primary units, instead of the comma, we generally keep the period, that is a dot, and we keep the precision at 0. Now we see that there is a rectangular box appearing on the object. We can remove that rectangular box if required, if not to be visualized. Okay, right? So once we have decided all things, we can increase the arrow side to 3, which is available under the symbols and arrows. So what we have changed? Symbols and arrows, we changed the arrow size to 3. In the text menu, we have changed the text alignment to ISO standard, and text placement is above. These are the only 3 things we changed till now. And in the primary units, we changed the precision from 0.00 to 0 and decimal separated as period. Now anyway, if you are going to take the precision at 0, period, that is decimal separator, will not be coming into the picture. So click on OK. Then we need to change the size of the already taken dimensions. So for that we need to press the set current and click on the close. In this way we see that these are the dimensions. Now you may see that the boxes are coming. These boxes are coming because there is one option which is available here, which is producing this boxes near the boundaries. Or you can change that. There are multiple methods in which we keep these dimensions. So if your choice is not to keep the boxes, you can remove those. Okay. Currently, I'm keeping those boxes. Okay. You can see here, draw the frame around the text. So I'm removing this draw the frame around the text. You can see the preview here. Click on OK. Click on the set current and close. We see that the frame is removed. Now we click on the dimensions. We show it the critical dimensions here. This 16. Again. In this way, we show it for the front view. Similarly, for the top view, we show it like this. First, you show the largest dimension. Then you can show the inside dimension, or you can start with the smallest dimension to the largest dimension in this way. Okay. Now we show the dimensions for the this part, which is total is 72, or we can show the 72 here also, because the width of the both is same. Now here we need to be very careful. Either we have to select the corners very properly, otherwise it may lead. See this. Some of the errors might occur like this if you are not select the proper corners, right? So look at this. This is 72, right? Then this is 24, right? This is again the same 24. Now always remember in AutoCAD that we need to avoid the double dimensioning. So we should not indicate this 24 again, because addition of all this will lead to 72, which is obvious thing, right? So now I join this, which was remaining, as I removed this because it is not matching here. Okay, this way. Okay. Now what is needed to be drawn? Another thing is that we give the text. What is it? This is front view, right? We can also increase the text height by selecting this. Let us keep it 5. Okay, we can keep it position based on the how much is the space available below the front view, or we can move it very close to the top like this. We might have to switch it off the ortho mode. So this is front view. We copy this, right? We place it here. We can move this dimension just little upwards. While moving, I'm switching off the snap mode so that it does not interfere like this. I'm moving this. I double click so that I can change. This is top view, right? I copy this and then I place it for left hand side view. We can also place it in between here, right? So here it is LHSV. Okay. So in this way we can show the front view, top view and side view. Okay. Today we will end up the lecture here. Thank you.